Welcome, ladies and gentlemen. This is Mr. Trippy here, and we're going to talk about question number 4 from your Thinking with Mathematical Models Investigation 3 quiz. And the problem starts out with Carl wants to save $1,000 for a trip. So we know this is his target. He's trying to save $1,000. And if we're taking a look at part A here, it just says complete the table and then draw a graph to show the data. So if we're looking here, the amount saved per week is going up by 10, 20, 30, 40, 50, 60, 70 bucks, and the number of weeks, how long it's going to take him to get to that $1,000. All right, that $1,000 is never changing. So right off the bat, I'm thinking, hey, this is probably going to be an inverse relation because we have this constant. So I'm going to go ahead and write my equation down. Y equals 1,000, which is your K value, over X. And what we're trying to figure out here, okay, is if I'm trying to get to 1,000 and I save $10 per week, how many weeks is it going to take me? If it helps, we always know that the X's are on top, Y's are on bottom. So if I want to fill that in over here, that's X, and the number of weeks is Y, go ahead. So now, if I save $10 per week and I substitute that into my equation, so 1,000 over 10, we know that that equals 100. So it would take 100 weeks if we're saving $10 every week to get to 1,000. Let's try and figure out what our next one is. So using my equation, Y equals 1,000 over X, but we know we're saving $20 per week this time. I do my division, and I see at $20 per week, it only takes me 50 weeks to get there. Going through the same process for 30 to 70, you should have found that for 30 weeks, if you save $30 per week, it takes 33.3 repeating weeks. Then let's check for $40 per week. That should have took 25 weeks. For 50, it took 20 weeks. For 60 bucks a week, it took 16.66 repeating weeks. And for 70 weeks, or $70 a week, you could get there in 14.286 weeks. So then we want to go ahead and set up a graph of this. So we all know that we need a title for our graph, so we can just call it Carl's Savings. I already know what I should label my X and Y axis. I'm just going from my table. So the amount saved per week and the number of weeks. Now let's take a look at the numbers that we have to get to. So my amount saved per week is just going up by tens. Starts at 10, goes to 70. That's a no-brainer. I'm going to go ahead and count, starting at 10, and just go up by tens on my scale. Then let's take a look at our y-axis. I have to get to 100. Goes 50. We do have some decimals in there, so I think the same thing will work if we just start at 10 and go up by tens. And then we're ready to just plot our points. So we can see at 10 we are at 100, 20 we're at 50, 30 we're at 33.3, 40 we're at 25, 50 we're at 20, 60 we are at 16.66 repeating, and at 70 we're at 14 then. And looking at your data points there, you can see it looks like we have that curve of that inverse relation. So now, in question B, it says, write an equation showing the relationship between the amount A saved per week and the number of weeks N. So we kind of already had the equation up here that we used to fill out the table a little bit, but remember, they want us to use A, and they want us to use N here. So a couple different options here. I'm going to write them all down, but you could have started out with A times N equals 1,000. That's probably your easiest equation to write down. And then you could have also had N equals 1,000 over A, or A equals 1,000 over N. Any one of those three would work for this situation, but you want to make sure that you're using the correct variables A and N. Now, let's take a look here at part C and D. Part C and D, well, part C here says, what are the changes in the number of weeks needed to save $1,000 when the amount saved per week changes from 10 to 20, then from 20 to 30, and then finally from 30 to 40. So what we need to do is we need to go back up to our table here, and we want to see how is the number of weeks changing. So what I'm going to do here is look, from 100 to 50, we went down by 50. So that's what I'm going to write here next to from $10 to $20. The number of weeks decreased by 50 weeks. But then when we go from 20 to 30, back up to my table. I'm looking here now. There we went down by 16.66, repeating. So the same thing from 20 to 30, count that down, that decreases by 16.66 repeating weeks. And then finally, looking from 30 to 40, so looking in there, that was a decrease of 8.33 repeating weeks. So decreases by 8.33 repeating weeks. Now this question ties into question D. Question D says, how do the answers in to part C show that the relationship between the amount saved per week and the number of weeks is not linear? And it's simple when you look at here. If this was linear, that would mean that it has a slope. It has a constant rate of change. And as I look at my numbers here, it's not decreasing by the same amount. If you look back up in your table, you should have a constant rate or a constant slope if it is linear. So, and that's what we just need to say in part D. This is one way that you could write it, but in part C, as the money goes up by $10, since we're constantly going up by $10 here, the number of weeks decreases by different amounts. Therefore, it is not linear. And that's what we'll be looking for on question number 4. Hope this helped clear anything up, and if you have any more questions, see your teacher. Have a good day.